All right, my loves, today we are capping off our study of systems of linear equations by looking at graphing systems of inequalities. I'm so excited because these are so fun to graph. But before we get started, we're going to put to the test our knowledge of how systems work, right? So remember, we can tell whether an ordered pair is a solution to a system of equations, or in this case, inequalities, if it makes both equations, or inequalities in this case, true when we plug it in. So let's go ahead and have a look-see here. So I'm going to take this -2, -1, and I'm going to plug it into both of my inequalities. Okay, so we're in a little like splitsy screen here. All right, so we're trying to figure out if it works over here and if it works over here. And the point in question is this -2, -1. So y is -1, x -2, -1, -2. All right, so let's take this one at a time. -1, not doing anything there. Is that greater than -6? It is. All right, so it works for that one. But remember, it has to be a solution of both to be a solution of the system. So we're going to check this guy. -1, is that less than or equal to? This is going to become +2 minus 2, which will be 0. And of course, -1 is less than or equal to 0. So therefore, right, this little symbol here means therefore, it's a solution to our system. And I'll talk about why I'm saying that it's a solution and not the solution in just a second. All right, part B. All right, we've got 0, 4. And same thing that we did earlier, right? I'm going to do a little splitsy screen. We're going to see what happens here. This time we're putting in this point 0, 4. So I'm going to have 4 is my y, 0 is my x. All right, so we got 4. Is that going to be greater than or equal to 0? Sure is. So it works with that one, but gotta check both. All right, so we're trying to see is 4 less than or equal to -0 is just 0, -2, which is -2. But 4 is not less than or equal to -2. So because, even though it works for the first one, because it does not make the second inequality true, this guy cannot be a solution. So I just want to remind you of that algebraically. What is it that we're looking for graphically when we are saying we're looking for the solution set to our system of linear inequalities? We're looking for all ordered pairs that make both of the equations, or in this case, inequalities in the system, true. All right. This is one of my favorites because we get to play with color. Who doesn't love that, right? So get out your favorite colors and let's get graphy. So we're going to graph the system of linear inequalities by graphing separately. All right, so we're going to graph, right, shade, because that's an important part of graphing inequalities. Each inequality, okay, the double shaded region, right, the overlap is where the solution set is. Alrighty. So let's go ahead. I'm going to graph this one blue and this one green. So y is greater than or equal to -1. So this is a horizontal line. Its y-intercept is at -1, and it has a slope of 0, so it's not rising at all, right? It's a horizontal line. And it's greater than or equal to, so that equal to sign, right, that looks like a solid line under my inequality, means that I can connect those dots with a solid line. And then because I want where y's are greater, I'm going to shade above. So I'm going to use my highlighter because I can. All right. Right, let's see what this highlight color looks like. Oh, okay. I'm vibing. All right, so we're going to highlight above that. There you go. Our solutions to that inequality. All right, but now we got to look at our green one. So, didn't really think this through. Green and oh my goodness, green and blue might not make the cutest overlapping region. Oh well. So this guy here has a y-intercept of +2, and he has a slope of -1. So I'm going to go down 1 over 1. Now it's strictly less than, so that means that I'm going to have to connect with a dotted line, and then we're going to shade below. All right, so I'm going to preset for this one. Oh, all right, there we go. She's cute. So we're going to shade below. What? I erased my work. Don't be like me. Sorry, sound effects. I just think this is so fun. Like, we get to color in math. How cool. There we go. All right, so like I said, double shaded region kind of came out. Not a cute color. We'll choose something with better vibes later. Maybe I should have stuck with my pastels. Anyways, that double shaded region right there. Here. So it was kind of poopy. So that double shaded region right there. That is where our solutions to our system are. So if I picked an ordered pair in there, like -4, 2, and I plugged it into both of our inequalities, I'd get out true statements for both. Next. All right, we're going to graph our system of linear inequalities here. Maybe we'll choose different colors this time. So let's go pink. I don't know. What do you think? Will look cute with pink. Purple? Purple, anyone? All right, so here we go. Let's graph the pink one first. It has a y-intercept at -1. And the slope of 1/3. So I'm going to go up 1 over 3. Kind of off my graph a little bit. I just put a little dot to eyeball where that would be. Okay. And then this also is greater than or equal to, so I know that I can connect my dots with a straight line, like so. There you go. Okay. Also, now we can shade above. Sorry. So I should have done all of my presets ahead of time. I just feel like it's more fun if we're doing it together. Okay. So now we can shade where Y's are bigger or above. It's like soothing. Oh no, except when I do that, I accidentally let go and then it starts double shading on itself. Nope, can't have that. This is where iPads can be so superior. Like, all right, you know what, guys? It's just not in the cards for me today, apparently. I apologize. Oh no, that's too ugly. I can't hear that. One more time before we give up. I don't know what's wrong with me. Am I coloring tonight? Okay, sorry guys. Oh, just hurts my soul to look at it. I'm sorry, everyone. Nope, can't do it, can't do it, can't do it, can't do it. Alright. If you're watching this, comment below and tell me, are you as crazy as I am? Or would you just leave it because who's got time to reshade this graph 1,000 times in one day? Oh, all right, it's like a stab to the soul. That was so much better. All right, now for our purple one, I'm gonna get my highlighter ready. Okay, that's better. Cool. We can go back to pen. This purple guy has y-intercept at +2 and a slope of 4/3. So this guy is gonna go up 4, which takes him slightly off my graph, and then over 3, like so, somewhere over there. And then we'll go down 4, over 3. Oh, there's a little intersection here. Cool. Down 4, over 3 would be slightly off the graph, kind of over here. All right, this also has a solid line because it's also a strictly, so connect those, there we go. And then this guy we're gonna shade below. So let's do it. Hopefully this goes a lot better than last time. All right, there you go. So you can see our double shaded region in kind of like the first quadrant there mostly is where our solutions to the system live. All right, last one of our typical examples. So go ahead, try this one on your own and come back and check it out. Alrighty. I'm going to go with blue and pink this time. Notice my equations here are in the standard form. So we can either, you could graph them to standard form, but then it would be hard to figure out where we're going to shade. So I'm going to rewrite these in y equals mx plus b, slope-intercept form, so that we can, so in Q number 1 goes here, and Q number 2 goes here. So it's just good practice. So I'm gonna subtract x from both sides. And then when I multiply both sides by -1 to cancel with the y there, I'm gonna have to flip my sign. So I'll end up with y is less than x minus 2. And then this guy over here, again, we're subtracting x. So minus x minus 3. And multiply both sides by -1. My sign flips. We're going to have x plus 3. Alrighty, so let's go ahead and graph the blue one first. So y-intercept down here at -2, slope of 1. It is exclusive, right? We're not including the points on the line, so I'm just gonna dash. And we want y's that are smaller, so I'll go ahead and shade below. Like so. Okay. All right, now the pink one. It has a y-intercept of 3, also a slope of 1. And this is inclusive, so we are going to connect our dots with a solid line because y is greater than or equal to. And then we're going to shade above. Because it says when y's are bigger than or equal to. There you have it. Notice that there's no double shaded region here. So because there's no double shaded region where they overlap, oops, means that we're going to have no solution, right? There's no shaded region, no overlap. There's no point that's going to make both inequalities true. All right. So now what I have going on here is I have actually given you a couple graphs. And the reason I did this is because I wanted you to see that sometimes graphs will only show the double shaded region and they won't have like all the different options. So here, each graph only the double shaded region is shown. Okay. Then I want you to find at least a point that is a part of each solution set and one that is not. All right, so first things first, we're going to use slope-intercept form. So this guy has a y-intercept of 3. Now it looks like it has a slope of 2, right? We're going up 2 over 1, up 2 over 1. So my first equation is going to look like y, some symbol, not putting it in yet, 3. Oh, geez, nope, my slope is 2. 2x plus 3. All right, well, it's going to be strictly whatever it is because it's dashed, right? So we're not going to have any equal to going on here. And it's shaded below, right? So that means we're going to have y is less than. This guy has a y-intercept at -1. And its slope is going down 1 over 3. So it's going to be negative 3x. Ooh, that 3 kind of looks like an 8, doesn't it? We should fix that. Alrighty. And here, we're kind of shaded above the graph. Again, exclusive, where I didn't include the points on that line. And so here's our system. Now, when I ask for possible solutions, right, these, right, may vary. So, like, I'm going to pick one for each, but you can certainly come up with ones that I didn't think of. All right, so for example, this point over here, negative 4, 3, that's not in the double shaded region. So that's not a solution. But this point here, positive 1, is in the shaded region, so it is a solution. All right, go ahead and try this one here. It's a little tricky because there's only that sliver that's not shaded. Okay, try it out. See what happens. I'm gonna come back. All right, so let's write our system here. Okay, now these remain slope-intercept form. Well, it looks like they both go through the origin, so their y-intercept is 0. Okay, so we'll just have to figure out the slope for both of these. So it looks like the top one is going up 3 over 1, whereas the bottom one is going up 2 over 1. So we're going to have 3x and 2x. Both of these are dashed as well, so we know that we're going to have just strictly greater than or strictly less than. And then it looks like we're going above that slope of 3 line, so y is greater than that, but we're going below that slope of 2, which is how we only have that sliver that's not shaded. All right, so for possible solutions, okay, let's see. So a possible solution, again, these are going to vary, could be like 3, 1, right? That's shaded. Again, you're going to come up with solutions that I don't. But for not a solution, this one right here, 2, 5, that's not included, right? That's not shaded. So that is not a solution. Again, those will vary. All right, friends, this has been so fun getting to make these colorful graphs for you and with you. This one, maybe not so much, to look at graphing systems of inequalities. I hope you enjoyed it, and you had a better time coloring than me because that one pink graph was kind of rough. All right.